try this again. And yeah, so NormConf is coming up next week. And there's a NormConf Slack, which you can find um, if you are so inclined. And someone in the NormConf Slack said they used match and case in today's solution, and I told them not to spoil it for me. But that's all I know about it. That they used match and case, so maybe I'll try and use match and case too. I've never actually used match and case other than a minute ago when I tried it out. So day 7, you can hear birds chirping and raindrops hitting. Um, blah blah blah. Louder sounds. Error, no space left on device. You save the resulting terminal output, your puzzle input. For example, CD ls dir a 14 this b dir d cd a ls dir e cd e. Also consider a tree of files, plain data, and directories which can contain other files. The outermost directory is called slash. You can navigate around the file system moving into listing contents. Within the terminal output, lines of with dollar or commands you executed, like some modern computer. CD means change directory. CDX moves in one level, looks in the current directory for the directory named X and makes it the current directory. CD dot dot moves out one level, it finds a directory that contains the current directory, then makes that directory the current directory. CD slash switches it to the current outermost directory. LS means list, file mean ABC, dir. Given this, you can file system looks visually like this. Here there are 4 directories, this, and this is full. Find directory 0 candidates deletion. To do this, you need to determine the total size of each directory, total size of the sum of the size of the files it contains. The total size of the directory is the file. Total size of directory E is 584 because it contains a single file and no other directories. The directory A has total size 94853, contains files F, G, and H plus file indirectly. A contains U, which contains I. Let's find all the directories with the total size of at most 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total size is this. As an example, the process count files more than once. All right. So, let us do this. So, this looks pretty somewhat involved. Okay. So, one thing I can do is one I can split on dollar space. So we're just going to do this a little bit interactively. So IPython, let's do this. Run day07.py. Okay, raw dot split on what if I split on new line that? No. Let's say x dot strip for x in that if x dot strip. Okay, so that's that. And so that seems good. And what we need to do is we need to infer a directory structure. So let us say that a directory is let's do a data class. From data classes, import data class. Okay, at data class, a file is a name, which is a string, and a size, which is an int. That's good. Data class, which is a directory. That's good. a name which is a string, and let's do a path, which is a list, and files, which is also a list. Typing import union. Okay, so a path is a list of strings, and files is a list of union of file and directory. Okay, so that should be good. And now, so let's say, actually, I don't think I need a name. I think I just need a path. Let me think about this. I'm going to make this a dict of strings and a union file and directory. So I think that will make my life easier. And say, think about what to do here. Learn file system raw, which is a string, and it's going to return a directory, parse the file system from the raw string, and return the raw directory. So I think that's right. And let's say root equals directory. Okay. And now I need to go back and get this thing here, which is commands equals okay, and let's say present working directory equals root, so we'll keep track of that. And then at the end, we're going to return root. Okay. And so for command in commands, so let's say, let's play with this. C dot split on new line for C in commands. So I have that, I have a CD, I have an LS. Okay. So for command in commands, let's say lines equals command dot split on new lines. And now here's where I'll use my match. Match lines case, and actually, case ls rest. Okay. And For A, B in rest is going to be this, this, this. Okay, so for listing in rest, match listing dot split with case size. No, so let's do case. I'm going to do dir and dir name. Okay, then pwb files dir name equals directory pwb path plus dir name. If dir name not in pwd files, pwd files dir name equals directory pwd path plus dir name and empty. Okay. And then case size file name. This is doing a lot of the work for me. I feel sort of guilty about that, but sort of not guilty about it. Okay, so now size pwd files file name equals file name int size. Okay, so that seems right too. Sounds good. And then otherwise, we have CD, okay? Match CD split. So if, okay. So that goes to root. So it might be easier to do parent as well. Parent union none directory equals none. Okay. So now this directory needs to do that, and pwd is the parent. Okay. So cd that, then we'll say pwd equals pwd.parent, and then finally we want to change into a dir name. And can we change into like compound directory names? cdx moves in one, no, so we can only go in one level. We can't go in any other levels. So parent is if pwd else pwd.parent else pwd. Okay. And then finally, case cd dir name. And now, do I need to assume that I know about that directory name? Dir e cde cdd. I don't think I want to assume that. So if dir name in pwd.files, pwd equals pwd files dir name, else cannot access member files for type file. Cannot access member. pwd should be a file. I mean, it should be a directory. Extension of type if dir name and yep. So let's say new dir equals dir name, assert is instance new dir directory, and pwd equals new dir. Let's see if that will let me do it, just because. And if dir name is not in pwd files, then I need pwd dot files dir name equals directory pwd.path plus dir name empty pwd. So that seems right. And then return root. And so let's say, let's go in here. Let's say fs equals learn file system raw, and let's see if that works. Directory no path, files A is a directory with path A, files E, directory path A, E, files I, parent F. That's okay, that seems reasonable enough. So now let's go to the second part. Find all the directories with a total size of at most 1,000 and calculate the sum of their total sizes. Find all the directories with a total size of at most 1,000. Some of the first. Okay, so now let us go back to doing this, and let us say all directories below root, which is a directory, and size int, which is, what did I say? 100,000, at most 100,000. And that is going to be an iterator of directories. So I need to go from typing import union iterator. Okay. And why don't I do this? I'll add size here. I hate doing that, but I'm going to do it anyway. And so now let me do int. It keeps saying discrete. Let's make sure I'm still streaming. Yeah, I'm still streaming. Okay, good. Okay. And let's say size equals 0 for file in dir.files values. If is instance, yep, so that's right. Oh, watch this. I'm gonna use match again. Match file case file let's say dir size. Yeah, that's nice. Dir size plus equals size. Um, and then case, um, I think I can do this. Dir size plus equals compute sizes file. Um, and then that should be good. Dir.size equals dir size. Okay. Um, so now after learn, let's add that to uh, compute sizes root, return root. So now um, let's run this again and see what happens. It's not defined. Okay, so let's move that up to the top. Sizes plus compute sizes file, because I need to return dir size to make the recursive part work correctly. Let's do that. And now let's do fs. Okay. And now let's do this. Def all directories below equals iterator directory. If root.size is less than or equal to size, yield root for file in root.files.values. And then that should work. And now what does the problem want me to do? It wants me to calculate the sum of their total sizes. Assert the sum of dir.size for dir in all directories below fs equals 95437. Okay, so now let us go run this. And that worked. Good. Okay, so let's get our puzzle input. And there's always a chance that it won't like my puzzle input, but that's okay. And so let's say with open day 07.text as fs equals learn. So let's say fs print sum dir size for dir in all directories below fs. All right, let's try that. I have this weird feeling that it's not going to work, but it's all right. Okay, it did work. Good. How are you to choose directory? Delete. The total disk space available to the file system is 770 million. To run the update, you need unused space of at least 30 million. Delete will free up enough space to run the update. The example above, the total size of the outermost directory is that. That means the size of the unused space must currently be this, which isn't quite. Therefore, the update still requires a directory with total size. To achieve this, you have the following options. Delete directory E. This is too small. Between these, choose the smallest D. Find the smallest directory that, if deleted, would free up enough space on the file system to run the updates. Okay, I didn't quite total disk space. So now let's see. Okay. Total disk size. Okay. Need unused size equals 30 million. So that means that max size 40 million. Okay. And so let's say use size equals fs dot size. Need to free equals, let's call this assert that need to free equals let's just make sure that we're doing the numbers correctly. Okay, no, that's so. Okay, let's see, fs.size is 48. Max size, oh, I did it backwards. Equals used size minus max size. Okay, so now that should be fine. And now what do I need to do is find, delete directory size. Candidate directories, root, which is a directory, and that's going to return an iterator over directories. Is that right? I think that's right. So, except I lost it. For file and root.files.values match file case directory. Why did that go away? So yes, but what I wanted to do was I wanted to do it like that, right? If size is bigger than or equal to need to free, yield file, and then yield from candidate directories file, otherwise pass. Okay. And so what I want to do is, let's say toDelete equals min of dir size for dir and candidate directories fs. So let me just like assert that. Assert min of dir.size and I think that's of fs. Okay, so now let us try to run that. That assertion worked, and we can delete this guy. That's not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. Okay, I'm using the full input data. So let's think about this. Let me do here is the problem. Uh, Actually, no, that's not a problem. That should be good. So I have a directory. If size is bigger than need to free, yield file, yield from candidate directories file, and otherwise it's not a directory, so we pass. So let me do just to see what I'm missing here. That's fine. Oh, I think I know what the problem is. This is the problem. Candidate directories, let me do this, need to free, which is an int. In this new file system, the amount we need to free is a different amount. Okay, so now now we're going to do this. I think that will be the issue because it's the answer is too high. That is the right answer. Okay, good. Okay, so dumb mistake, but it's fixed now. So what was interesting here? Not much really. That's one of the problems. Was more tedious than interesting, which happens a lot in Advent of Code. But anyway, we use data classes for files and directories. We ended up adding size here and populating it later. There's probably a way to populate it on the way in, but I didn't bother. We have this recursive formula for computing sizes. That's straightforward. And then all this parsing stuff for learning the directory. We set up a root directory, split on dollars because we know that's a command. And then for each command, we split on new lines to get it. When it's a ls and you get a bunch of file names, you go through each listing, split it, and get either a directory or a file and write it there. Otherwise, it's a change directory, and then you split that and either go up to the root, go up one level, or go down one level. We were a little bit defensive here about making sure things exist, but you can do that. And then after that, it's all just like iterator stuff. And then they put this in a confusing way, which is why it confused me, which is why I got it wrong. But um, then I got unconfused, and then I got it right. So that's that's that. And yes, this is day 7. Yes, this is day 7. I never remember to change the name of the stream. Sorry. Um, so yeah, so that's that, and I will see you tomorrow.